Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the video on partial fractions, and in this example I'll be talking about when you have 3 linear terms on the denominator. So here I have express 13x plus 7 over x squared minus 1 x plus 4 in partial fractions. Now the key thing here is the word I use, it's linear terms on the denominator, and one of those terms on my denominator is not linear. It is a quadratic, it's x squared minus 1. So what am I going to do to get to 3 linear terms? Well, it's my old friend difference of 2 squares again, isn't it? So this x squared minus 1 can be factorised to be x plus 1, x minus 1. Don't forget about the x plus 4. There's my 3 linear terms on the denominator. So 13x plus 7 on the numerator. And what I'd now be saying is, because I've got 3 terms on my denominator, I'm going to need 3 partial fractions. So a over x plus 1 plus b over x minus 1 plus c over x plus 4. And it doesn't matter which of these 3 terms you put a, b or c over. You can do it in any order you wish, as long as you put the numbers that you get correctly back into your algebraic statement. And then the process is much as in the first example. We need to obtain a common denominator on the right hand side that's the same as this, and then we work through from there. Now let's just be a little bit careful. With this one here, we already have an x plus 1, so what we would need is x minus 1 and x plus 4. So the a is going to be multiplied by x minus 1, x plus 4. The b, we already have x minus 1, so we'd need to multiply that one by x plus 1 and by x plus 4. And the c, we already have x plus 4, so we need to be multiplying that by x plus 1, x minus 1. Now, because I'm adding them together, they're all over the same common denominator. That was the point of doing that, so I'm just going to write it once, x plus 1, x minus 1, x plus 4. And that is the same as this statement here, 13x plus 7 over x plus 1, x minus 1, x plus 4. And then just as in the previous example, because we have the same denominator, we can say that the numerators must be equivalent, and then we can go on to find the values of a, b and c. So numerators are equivalent. What that means is that 13x plus 7 is equal to a lots of x minus 1 x plus 4 plus b lots of x plus 1 x plus 4 plus c lots of x plus 1 x minus 1. Okay, and now just have a think about which x values I'm going to substitute in to find a, b and c, thinking that what I need is for one or more of the brackets to go to 0. So the first value I'm going to choose for x is, I'm going to choose x is 1. So if I make 13 times by 1 plus 7, now that is going to make this bracket here go to 0, and this bracket here go to 5. If x is 1, I'm going to have b times by 2 times by 5, and if x is 1, I'm going to have c times by 2 times by 0. So as you can see, these 2 terms here, because I'm multiplying by 0, are going to disappear. So 13 lots of 1 plus 7 is 20, is going to equal 2 times 5 is 10, so 10b, which means that b is 2. And I'll box that because I now know the value of b. I'll put that into my final answer later on. Okay. The next value of x I'm going to choose, again thinking that I need one of the brackets to go to 0. I've used x is 1, so if I look at this next bracket here, if I use x is negative 4, that's going to make that bracket go to 0. So if x is negative 4, 13 lots of negative 4 plus 7, that's substituting x in here, equals, now if I substitute x in here, I'm going to have negative 5 and then 0 plus b. If I substitute negative 4 in here, I'm going to get negative 3 and then 0. And then with c, if I put negative 4 in here, I'm going to get negative 3. And if I put negative 4 in here, I'm going to get negative 5. So again, we can see 2 of the 3 terms on the right hand side are going to go to 0, leaving me with just one value to find. 13 lots of negative 4, negative 52, plus 7 is negative 45. 0, 0. Now, just be careful here with the sign C. Negative 3 times by negative 5, so it's positive 15c. So dividing negative 45 by 15, that means that c is negative 3. We'll talk about how to put that in the answer in a moment. Okay, final value for x then. I've used 1 to make that bracket go to 0. I've used negative 4 to make this bracket go to 0. The final value I'm going to use is negative 1 to make this bracket go to 0 here. So if x equals negative 1, 13 lots of negative 1 plus 7, substituting x in here, equals a times by, right, negative 1. So we'd have negative 2, and we'd have positive 3, plus b, negative 1 goes in here, we'd have 0, negative 1 goes in here, we'd have 3, plus c. Negative 1 goes in here, we'd have 0, negative 1 goes in here, we'd have negative 2. So just with the previous 2, we've got 2 of these terms going to 0, and I'm going to find the other one. Negative 13 plus 7 is negative 6. Again, be careful with signs here. Negative 2 times 3 is negative 6, so it's negative 6a, which means that a is positive 1, dividing negative 6 by negative 6. Right, so I've found the value of a, the value of b, and the value of c. So all I need to do now is to rewrite my expression with those values put into the right hand side. So what I have worked out is that 13x plus 7 over x plus 1, x minus 1, x plus 4 is the same as, right, a over x plus 1, so 1 over x plus 1. Remember, be careful that you get the correct values in the correct place, because you probably won't have found them in the order that you need to write them. Plus b over x minus 1, b is 2, so plus 2 over x minus 1. And finally, plus c over x plus 4. However, c is negative 3, so rather than writing plus here, I'm just going to put minus there, and then put 3 over x plus 4. And that is how to split this expression here with 3 linear terms on the denominator into 3 partial fractions. Job done.